Okay, so we're making our video for chapter 10.5. We are on page 767 in our books. We're looking at our chapter review. We're going to work through 5 problems. Let's start with number 56. So it says the square root of 3 times 2 square roots of 6 plus 4 square roots of 15. Okay, so we're going to multiply this like we normally multiply with our polynomials, right? So the square root of 3 is on the outside, so I must distribute and multiply him by every term in the inside of the parentheses. So the leading coefficient here is a 1. So remember, it's coefficient times coefficient. So coefficients multiplied together. Keep the root. And I guess I should say keep the nth root. Hold on. Keep the nth root, whatever it may be, and multiply the insides together. Okay, so 1 times 2 is 2. Keep the square root. 3 times 6 is 18. Great. Plus 1 times 4 is 4. Keep the square root. 3 times 15 is 45. Okay? Then our last step is to simplify. You always want to simplify. So, how do we break down 18? Well, it's 9 times 2, and 9 is 3 times 3. So 18 is the same as saying 3 squared times 2. And since this is a square root, we're interested in powers of 2. So this becomes 2 times the square root of 3 squared times 2, plus 4 times the square root of, well, 45 breaks down into 9 times 5, and again 9 is 3 times 3. So 45 is the same as saying 3 squared times 5. So 3 squared times 5. And again, of course, the square and the square root cancels out, so the 3 comes out. So that's 2 times 3. But this 2, he's still inside, so I still have the square root of 2. Plus, well, again, the square cancels out, so this 3 comes out. And that's 4 times 3, and the 5 is still on the inside. So the final answer is 6 square roots of 2 plus 12 square roots of 5. Alright, just a recap. Remember, coefficients multiply together. Keep the nth root. Multiply the insides together. Alright, let's see number 59. Let's see what we got here. Okay, well, I did the wrong problem, didn't I? I didn't do number 56. I did number 55, so now I'm going to do number 56. I apologize for that. I should work on my eyesight. Alright, number 56 is the cube root of 5. So I have the cube root of 5 times, or parentheses, the cube root of 50 minus the cube root of 2. Close parentheses. Let me look that over one more time. Cube root of 5, parentheses, the cube root of 50 minus the cube root of 2. And let's multiply these together. Well, again, because the cube root of 5 is on the outside, I must distribute him inside the parentheses. So each term inside the parentheses will be multiplied by the cube root of 5. They are also cube roots, so I'm allowed to do this. The coefficient out here is a 1, and the coefficient here is a 1 as well. So 1 times 1 is still 1. keep the cube root, and then 5 times 50 is 250. Yep, had to make sure I can multiply correctly. Good. Minus, again, this coefficient's 1, so 1 times 1 is still 1. Keep the cube root, and then it's 5 times 2, which is 10. And now we get to simplify. Well, 250 is the same as saying 25 times 10, and 25 is 5 times 5. And 10 is 5 times 2. However, since I'm, oh actually, no, that's right. So this is the same as saying 5 to the third power times 2. 10 is just 5 times 2. It doesn't break down any further, so it won't simplify any further, so I'm going to leave that one alone. But this becomes the cube root of 5 to the third power times 2 minus the cube root of 10. And then, of course, the third power cancels out with the cube, and the 5 comes on the outside, leaving the 2 on the inside. And this one, we cannot change. So your final answer is 5 times the cube root of 2 minus the cube root of 10. Great. Now let us work on number 59. Alright, number 59. What do we have going on here? Well, it says the square root of 5 plus the square root of 8, whole thing squared. So the square root of 5 plus the square root of 8, whole thing squared. Well, first thing we gotta do is write this out. Square is the same as saying the square root of 5 plus the square root of 8 times the square root of 5 plus the square root of 8. And then we're going to multiply this out using our FOIL, which basically says each term in the first group is going to multiply each term in the second group. Each term in the first group is going to multiply each term in the second group. So the square root of 5 times the square root of 5, well, the rule is to keep the square root and multiply the insides together. The coefficients are 1, so I'm going to skip that. 1 times 1 is 1. And then we're going to do the next one. The square root of 5 times the square root of 8 becomes the square root of 40, plus the square root of 8 times the square root of 5, again it's the square root of 40, and the square root of 8 times the square root of 8 is the square root of 64. So then the square root of 25 is just 5 plus, well, these are like terms, and since they are like terms, the rule is to keep the radical the same and add the coefficients together. The coefficients are 1, so 1 plus 1 is 2, so you have 2 square roots of 40, plus, well, the square root of 64 is just 8, and then put my like terms together, I have 13 plus 2 times the square root of 40. And actually, I'm going to simplify the 40. So let me erase it right here. We can simplify 40. 40 breaks down into 4 times 10. And 4 is the same as saying 2 times 2. So this becomes 2 squared times 10. So then I have the square root of 2 squared times 10, which makes this 13 plus, well, the square and the square root cancel, so this 2 comes on the outside and is going to multiply. So this becomes 4 square roots of 10. Okay, so those are problems 55, 56, and 59. And the instructions, since I forgot to read those, was multiply as indicated. And if possible, simplify. Now let us work on numbers 63. Shoot, what numbers am I working on? 69, 73, and 77. here we're going to focus on rationalizing. So, number 69. One second. Alright, what do we have here? 5 divided by the fifth root of 32, x to the fourth power, y. And your instructions say rationalize each denominator. Simplify if possible. Okay, well, when you rationalize, you want to get rid of the radical in your denominator. In order to get rid of the radical in your denominator, the power on the inside has to be a 5 because the root is the fifth root. So let's break down 32. 32 is the same as saying 2 to the fifth power. So this is the same as saying 5 divided by the fifth root of 2 raised to the fifth power, x to the fourth times y. Now, in order to get the radical out of the denominator, you must multiply it by the fifth root of something, and this something is going to be chosen so that every power inside your radical is the fifth power. Well, 2 to the fifth, he's already taken care of, so I'm not going to worry about the 2. However, x to the fourth, how many more x's do I need in order to make this power a 5? The answer is 1. This is y to the first power, therefore I'm going to need 4 more y, so I have y to the fourth. And then whatever you do on the bottom, you must do on the top. And then go ahead and multiply. So the top stays 5 times the fifth root of xy to the fourth divided by, well, this becomes the fifth root of 2 to the fifth, x to the fifth, y to the fifth. Then, because all of these are to the fifth power, the fifth power and the fifth root cancels out, and the 2, the x, and the y comes out of the radical. So I have 2xy, and on the top I still have 5 times the fifth root of xy to the fourth power. And then since our goal was to get the radical out of the denominator, and there is no radical down here, we have completed the problem. Now on to number 73. Okay, 73. So now I have the square root of x plus 5 divided by the square root of x minus 3. Okay, and my instructions are still to rationalize the denominator. Now, unlike number 69, 69 had a single term in the denominator. Therefore, I had to multiply it by the same root, but I had to choose the inside so that everything was raised to the fifth power. This time, I have 2 terms in my denominator. So you're just going to multiply top and bottom by the conjugate. So it's the square root of x plus 3. Top and bottom, the square root of x plus 3. That's where you're going to multiply by. And of course, we're going to get to use our FOIL from before. So the square root of x times the square root of x, well, that is the square root of x squared. And actually, you know what? I am going to skip some steps. And you work out the steps on your paper and make sure they actually match with me. This becomes x. Then the square root of x times 3 is plus 3 square roots of x. Because remember, the 3 is by himself. He's literally on the outside. There is no radical here, therefore I wouldn't multiply him by the x. Then we get to do 5 times the square root of x. So I get 5 square roots of x. And then lastly is 5 times 3. Which is 15. And then we're going to do the same thing in the denominator. The square root of x times the square root of x, again, is x. I'll let you verify that. The square root of x times 3 is positive 3 square roots of x. Negative 3 times the square root of x is minus 3 square roots of x. And negative 3 times positive 3 is minus 9. Okay, let's put our like terms together. So I have x plus, well, I have 3 square roots of x, 5 square roots of x, so I really have 8 square roots of x, plus 15, divided by, well, the middle terms cancel out, and I just have x minus 9. And notice that there's no radical in your denominator, so you have completed your goal of eliminating the radical. Alright, last problem, number 77. We have the cube root of 3x divided by the cube root of y. Okay, and the instructions this time are to rationalize each numerator. This time we're working with the numerator instead of the denominator. Therefore, I have a single term up here, right? And everything's raised to the first power. Okay, everything is raised to the first power. So my root is a 3, so the power on the inside has to be a 3. So I'm going to multiply by the cube root of something. And this something is going to be chosen so that the powers on the inside are 3's. Well, I have 3 to the first power, so I'm going to need 3 squared. I have x to the first power, so I'm also going to need x squared. What I do on the top, I must now do on the bottom. And let's multiply. Well, it's the cube root times the cube root, so you keep the cube root. 3 times 3 squared is just 3 to the third power, since I have 3 3's now. X times x squared, again, is just x to the third power. And then the denominator, again, I have the cube root times the cube root, so I keep the cube root. And I have 3 squared, x squared, y. And then, of course, let's simplify. So since all of these are raised to the third power, they cancel with the cube root, and 3x comes on the outside. Divided by, well, can I clean this up down here? I cannot, so I leave it as the cube root of 9 x squared y. Okay, so let's recap here. If there is a single term and you were told to rationalize, you're going to multiply it by the same root. So you're going to keep the root. If my pen can work, keep the root, and you're going to multiply it by something so that the inside powers are perfect. You might have to just listen to me carefully. Okay. Keep the root. Keep the same root, but you're going to multiply it so that the inside powers are a perfect nth root. So let's say I was dealing with the square root. Then I want my powers on the inside to be 2's. If I was dealing with the seventh root, then my powers on the inside would have to be to the 7th power. If it was the 9th root, like literally the 9th root, then powers on the inside would have to be 9's. Okay? That's how you eliminate the radical. If it contains more than one term, let's start over. If it contains 2 terms, then to get rid of the radical, you're just going to multiply by the conjugate. And remember, the conjugate of a plus b, can I get it? Conjugate of a plus b is just a minus b. Change the sign. And the conjugate of a minus b is just going to be a plus b. Remember, just change the sign. Keep the order of the terms the same and change the sign. Alright, that concludes the video for 10.5. As always, let me know if you have any questions.